How is magnetic flux linkage used in Faraday's law? Have you ever wondered how electricity is generated from motion? The answer lies in a fascinating principle known as Faraday's law, which involves magnetic flux linkage. So, how does this concept work? Let's break it down. Magnetic flux linkage is essential in understanding how electromagnetic induction operates. It represents the total magnetic flux passing through all the turns of a coil. To put it simply, it is calculated by multiplying the number of turns in the coil by the magnetic flux through a single loop. This relationship can be expressed mathematically as flux linkage equals the number of turns multiplied by the magnetic flux. Now, according to Faraday's law, an electromotive force is induced in a coil when there is a change in the magnetic flux linkage over time. The induced electromotive force is directly proportional to the negative rate of change of flux linkage. This means that if the magnetic flux linkage changes quickly, a higher voltage is produced in the coil. The negative sign in the equation indicates that the direction of the induced electromotive force opposes the change in flux, following Lenz's law. From the perspective of electrical engineering, magnetic flux linkage is a key factor in determining how effectively a coil interacts with a magnetic field to generate voltage. It takes into account both the strength of the magnetic field and the geometry of the coil, which makes it vital for designing transformers, inductors, electric motors, and generators. One important point to remember is that increasing the number of turns in the coil boosts the flux linkage, which in turn increases the induced electromotive force for any given change in magnetic flux. Additionally, any changes in the strength of the magnetic field or the relative motion between the coil and the magnetic source will alter the magnetic flux, thus affecting the flux linkage. In practical applications, Faraday's law and magnetic flux linkage explain how transformers transfer energy between circuits and how electric generators convert mechanical energy into electrical energy. Inductors also relying on this principle to store energy in magnetic fields. Understanding magnetic flux linkage allows engineers to optimize these devices for better performance and efficiency. So next time you think about how electricity is generated or transformed, remember the vital role that magnetic flux linkage plays in Faraday's law and the world of electrical engineering.